So in artificial intelligence and soft computing, today we'll see the problem solving techniques. So in artificial intelligence, the problems can be solved by using a different searching strategies. Out of these, the two main searching strategies are nothing but informed search and uninformed search strategy. So this informed search is nothing but some sort of hint information which will be provided along with the initial state as well as goal state. And uninformed search strategy is nothing but along with the initial state and goal state, no information will be provided to help a searching strategy or to help a searching process. So uninformed search strategy will be provided along with only initial state, means from where to start, and only a goal state, where to stop. So it is not having any help information. And informed search strategy will be having from where we should start, that is initial state, and where we should stop, that is nothing but a goal state, as well as some sort of hint information will be provided by a heuristic value or by generating one of the function which is called as a heuristic function that we'll see later on. So uninformed search strategy will be conducted by using a different searching processes. So out of these, the first searching strategy is nothing but the breadth first search strategy. So how this breadth first search strategy works? It is a type of strategy which is working or which is exploring a nodes level wise. Suppose we are dealing along with this particular problem. So this problem is having suppose a initial state that is nothing but a and a goal state that is nothing but a h. So we should start from this particular state for a searching process and we should end our searching process as we'll reach to this particular goal state. So by considering this particular tree, we'll start a searching process at this particular node. So A is our initial node. So we'll start a searching process from A. We'll first check whether A is a goal node. If A is a goal node, then print succeed. If A is not a goal node, then we'll check whether it is having successors. So A is having a successors B, C and D. So we'll explore this particular successors if A is not a goal node. So we'll use one data structure which is called as a queue data structure, which is using a first in first out strategy. So as if A is not a goal node, then we'll explore these three nodes. Okay, we can pick up any one first and we'll add them one by one to the queue. Suppose we are adding this node B first, then C and then D. Then next, when we'll check regarding to a searching process, if A is not a goal node, then B is a front end element of our queue. So we'll check whether B is a goal node. If B is not a goal node, then we'll check whether it is having successors. So B is having two successors, E and F. So if B is not a goal node, then we'll check these two and we'll add them to the rear end of the queue. So our queue now consists of node C at the front end, then D, then E or F. Okay, as we are exploring them, we can explore E first or we can explore F first. So we'll add them to the rear end. So in this way, we are searching level by level. We are checking at this level, we are checking at this level, then we are going to the next level. So this is also called as a level wise searching strategy. So now we'll see the actual algorithm of this breadth first search. So as shown in the diagram, A is our initial node. So for this algorithm, we'll use for doing this searching strategy, we'll use two queues and one variable. The two queues are nothing but first is nothing but a closed queue which will consisting of a visiting nodes or which will be utilized for adding a visited nodes, and open is a queue which will be utilized for opening a newly open nodes or placing a newly open nodes, and X is a variable which is equalized to a particular goal node. So we are opening A first, we are checking it across a goal node. If it is goal node, if it is equal, then we'll say that the goal node is achieved, print succeed and stop there. If A is not a goal node, then we'll place or before that we'll check whether it is having successors. If it is having successors, we'll add them to the rear end of the queue and we'll close that particular node A. Now we are having these three nodes, so B is coming at the front end element of our queue, as we are adding a B first, then C, and then D. So we'll cross check the front end element across X. So if it is a goal node, print succeed and stop there. If B is not a goal node, then we'll check whether it is having successors. Now B is having two successors, E and F. So we have open E first and then we have open F, and we are adding them to the rear end of the queue. So we are having now the queue consisting of C, D, E, F. Okay, now the front end element is nothing but a C. Now we'll cross check C across X. In this way we'll go on exploring each level. So as we'll reach to a node H, now H is nothing but our goal node, so it will be equal. Okay, when we are conducting a searching process, it will be equal. So when we'll get this equal, we'll print succeed and stop there. So this is algorithm for a breadth first search strategy. We'll explain that algorithm stepwise like this. Step number 1, create a single member queue comprising of a root node. Okay, or we'll say, instead of saying a root node, we'll say a initial node, that is a open queue. Step number 2, if first member is a goal node, go to step number 5, that is nothing but a print succeed and stop there. Step number 3, if first member is not a goal node, then remove it from queue and add it to the list of visited nodes. Consider its children, if any, and add them to the rear end of the queue. Step number 4, if queue is empty, go to step 6, else go to step 2. Step number 5, print succeed and stop, that we have seen at the first node if it is a goal node, or wherever we are getting a goal node. Step number 6, print fail and stop. Okay, so for constructing this particular searching strategy, we have used first in first out data structure, okay, which is nothing but we have utilized here open queue as well as a closed queue. Okay, so this is all regarding to a first uninformed search strategy, that is nothing but a breadth first search strategy.